Good evening, colleagues, who are joining us at the 4th International Congress on Mathematical Education with the topic Transforming Mathematics Tasks, an important mathematics teacher's role. The work team is integrated by Guillermina, Liliana, and Victor. The relation of the work with TSG30A show the combinatorial analysis for the teaching and using formula and where mathematical ideas come from. Also involves Pascal's triangle is a triangular scheme at numbers in whose vertex there is one corresponding to formula. In the second row, there are two numbers, one which will correspond to the coefficient of A and B respectively, and the problem statement is then formulated. Scalar quantity expressed with a single real number and an unit of a measurement such as the length or the distance between one point and another. On the other hand, task design, making sense of mathematical ideas, wrote the taxi-y problem. Vector quantity, a quantity that in addition to a numerical value and units of measurement requires direction and sense, such as displacement. Task design, the elements of task design, the nature of the mathematics on which the task focus, and the processes of task design. In physics, the relation of combinatorics and the problem proposed of the possible routes that a cab driver must follow to find the minimum trajectory. Teachers or designers facilitate learning by making sense of mathematical ideas and showing their usefulness. Thus, the problem proposal on combinatorial analysis represented a change for the students. The proposed problem is in physics and is oriented to the possible routes that can be found when three people wear a different cap that takes them from point E to point B, where students as attacked graphically represent the solution, detailing the possible path that each of the cab drivers must reach the destination of each person. This is where they make use of combinatorial analysis and scalar and vector quantities. Students consider scalar and vector quantities where they consider the equation to determine the possible combination without repetition. The teacher has worked on their planning based on the Phi-E model. The problem statement involves the situation proposed by the teacher that combines questions oriented to mathematical reasoning in combinatorial analysis. As part of the teacher's planning, the Phi-E model is carried out consisting of 5 phases: engage, explore, explain, elaborate, and evaluate. The situation and question and model Phi integrated worked.
Next, we will describe the transformation that attacks of the combinatorial theme underwent with the Pascal triangle, working it with an active teaching methodology that proposed to move through the process of model Phi-E. First, engage. Interest is generated among students through the questions: what instructions would give a blind person to move from a certain place to another point? Consider that you cannot take it by the hand, just give instructions. It is an uncommon situation. The blind person is usually helped by taking them to the place, but the situation is only to give instruction. The participation of the students who obtains correct results has been promoted so that other students reconsider the solution to the problem. Students has also to introduce to exemplify the scene of the situation for really consider the trajectory. Students receive feedback from classmates and perform the situation to reconsider the possible paths that should guide the blind person. The taxi driver's problem represents a challenge for the students, and the suggestion of the combinatorial analysis and the Pascal triangle serves as a preamble to generate interest in solving problems. The result obtained was 85% of the students represent and calculate the combination that the taxi driver has to go from point A to B. The 15% of students solve only using the Pascal triangle without carrying out calculations. Explanations. Students are being introduced to inquire about solution strategies. The teacher asks questions that cause the application of the Pascal triangles. The students work the taxi driver problem graphically over a period of 2 weeks without being able to correctly relate the combinatorial analysis. The use of Pascal triangle for situation I has been suggested. The result of a 90 corresponds to students who attempt to apply Pascal triangle in solving problem, while the remaining 10% argue did not understand the relations of the problem with the combinations. The brainstorming strategy has been considered for the recovery of the knowledge of the students group and thus guide them towards the solutions. The next step is elaborations. Students are encouraged to apply the existing combinations in the problem from the use of the Pascal triangle by explaining the possible combinations. The results represented by 34 students are through the use of a graph, using a reference system and representing Pascal triangle, in addition to including combinations with mathematical calculation verifying its results. Situations 2 and 3 proposals were resolved by applying a combination analysis for situation 1. The 90% of students correctly execute the Pascal triangle model for the explanation of all the combinations found for the taxi driver problems. Thus, so by representing the combination and making calculations, then makes a comparison of results that they are of the same values, so check that all your calculations have the same result. Evaluations. The students' work carried out of the phases described above were being taken into account. A questionnaire on scalar magnitudes has applied. The importance of relation with the combination and the Pascal triangle. In the evaluation phase, students represent the result with their classmate. The students arrive at the result applying the combinations to find the possible routes relating on the Pascal triangle. The solutions were being shared in the classroom and were being complemented in minimal details. Since some students added iconic representation in addition to including the graph with reference systems. All of this work of students and on the teacher are following the model 5E: engage, exploration, explanation, elaboration, and evaluation.
By way of conclusion, we can conclude that the mathematical work that the teacher does in class is related to their ways of learning mathematics. The teacher faces new challenges. The ways of learning of young students now demand greater creativity from the teacher. Motivating students, hooking them to take ownership of the activities, and for them to achieve mathematical arguments give a satisfactory vision of the work done. Contextualizing mathematical problem, take them to a real world, and finding the mathematical relationship offers students new ways of mathematical thinking. The possibilities of theorizing the work of the students and their relationship in the development of the teacher's work are endless. Let us make them come true. Thank you for your attention.